Hello, it's Duncan. One problem with handwriting a parser, as we have for the JSON parser that is the subject of this series, is that it's hard to know for certain that it works properly. That's true for most of the code that we write, of course, but parsers are usually implementing a rigorous and externally defined specification. Another consideration for a JSON parser is that it's often exposed to potentially malicious input, so we would like to know that it's safe to be left alone on the internet. Now that our parser is apparently working correctly, I had thought that I was going to have to write code to generate a wide range of inputs to check its safety and conformity. Luckily, I found that somebody had already done this job for me, so today we just have to cut and shut our code to their tests, understand what they mean, and fix any issues they find. Well then, that's pretty much the end of our to-dos for a JSON parser. I think maybe our error messages would be better if they gave us a line and a column number, but that can wait. The major question in my mind is, what have we missed through this process? Now, I have done a bit of research and come up with this article, albeit from the last decade, on the issues involved in parsing JSON, and it's backed by a set of test files. And they are in this repo on GitHub. Now, I've checked this out. The repository includes some Python to invoke your parser and generate a report, but we'd have to build an executable of some sort, and it would be launched for every one of the files, which isn't very efficient in Java. So I think maybe we'll use the files for this test suite, but through our own harness. And the files begin with a Y, an N, or an I, depending on whether they should be accepted or should be rejected. Note, it doesn't tell us what the result should be, just whether or not we should have a result. So if we have a look at the files in here, they're in this test parsing, and you will see there are a large number of them, and each one contains some JSON, which, depending on the file name, should or should not parse. So this one begins with an I, which means we could pass or fail, I suppose because it's such a big number. Okay, so let's go and write a test. I'm going to create a new test, and that was JSON Test Suites. So I'm going to put JSON Test Suite tests and add. And the gist of this is that we're going to start off in a directory which is checked out in the level above us. So it's going to be up one into JSON Test Suites, and then it was test parsing inside that. So let's take this string here and say we want to find everything in there. Oh, maybe not like that. That will sigh. We're looking for that / that. So let's first of all write a test, which is a test, and let's just see what's in that directory. So we'll do dir.list files for each println it, where it, I hope, is a file. So let's run that, check we're looking in the right directory, and it looks like we are. Good. And now for each one of the files, we will try and parse it. Now our interface doesn't take a file, it takes a string. So I think we'll say, let's print the file. And then we'll say val contents is file.read text. And we need to give it a character set. And I believe that JSON by default should be read in UTF-8. So we say charsets.utf8 to make it clear. And now let's parse our file. So we know that can throw. So we'll say try parse contents. And that is going to be our result. And we expect that sometimes that will fail with some sort of exception, maybe even some sort of throwable if we're doing very badly. Now then, have we passed or failed? Well, that would depend on the file name. I'm going to create a status string here, I think. So I'm going to call this status, which is a string. And if we got a result, then if the file.name starts with an N, which means we shouldn't have got a result, then status is fail, else status is pass. And I think IntelliJ is telling us that we could make that into an expression like that. Now what happens if we catch a throwable? Well, we can assign to status the other way around. So we can say if it starts with a Y, but we caught something, that would be a fail, otherwise it would be a pass. Now it's interesting, the compiler thinks that we are trying to reassign to this status. I suppose that might be the case if this expression itself was to fail. We'll come back to it, but just it's a var for now. Okay, and now for each one of these things, let us print them the status. And I think maybe we will do the file and the status so we can see them. So we'll print the $status and then $file.name. Take that one out of there and see what we get. And there we go, 16 seconds. But things like array is an empty string, that shouldn't have failed and didn't. But for example, string unescaped control character has failed. It should have thrown, but we didn't by the look of things. Now let's count the number of passes. There were 301 passes, and count the number of failures. 17 failures. Well, that's not bad at all, I don't think. Let's see if we can give ourselves some more information to see what's going wrong. I think I might like to see what was in the file, so we could put that in here, and we'll put it in our angle brackets of $contents, and then I think maybe we'll say var result, which is any question mark. We can assign to it in here by taking that off, and in here we can say result equals, let's take our X message, and then we can put the what the contents maps to in another angle bracket of result. Run that. Okay, oh, there's a big file in there by the look of things. Oh, let's stop this. Oh, it stopped itself. Let's say contents dot take 100 characters. Need to put that inside braces. And just in case we get the same thing, I think maybe we'll say result dot toString take 100 of those as well, and run. So going back up to the top, our first failure is we had a file with an unescaped control character in it that we successfully parsed. And that's interesting, that wasn't actually a parser, that was reading the file here, in fact, using file read text with UTF-8. I think I'm going to have to think about what to do about that. Let's go and have a look at the next failure. Okay, here's a failure. We were parsing an array with a -2 dot in it, and we returned -2. And that should have failed, I guess, because a trailing dot is not allowed in a number. I suppose we could fix that, but it looks pretty unambiguous to me. I think I'm going to leave that one alone for now as well and go down. Next failure. Okay, next failure is a number with a leading 0. And again, that's unambiguous, just not in the JSON grammar. We could fix it, but it's not high on my list. And the same is true here of an unescaped tab. You see that there's a tab inside this string here, and we are returning an array of a string with a tab. And again, I think there are worse behaviors. Down, down. There's a fail again, a number format. So far I think we're doing quite well. Here's an embedded new line. Again, that's about reading the text of the character set of UTF-8, rather in fact than our parser, which starts from a string. So looking down through here, I'm not seeing any heinous crimes of parsing, which is really quite impressive given the way we've written this. Now we might go through and check our error messages. That would be another interesting thing to do, but I'm just looking for other issues. So this, what is that? 100,000 opening arrays. We returned null. Well, I can't believe we actually returned null from that, so I wonder what that was. What I think we'll do is write a test to find out. So that's this file here. Let's add ourselves test fun specific, And we say the file we want to read is a new file inside the directory with the name that we remembered. And then we'll do this, followed by at, and let's see what we get out if we run that. Well, it has failed, so it looks like it threw. What did it throw? Oh, we've got a space in there, idiot. There it is. Run again. This is going to take its time if it's starting 10,000 arrays. Yes, most of our time seems to be spent here. There we go. And what do we get? All the way at the top. Well, we're failing with a Stack Overflow error. And I guess this is because each array state is in turn creating another array state and so on. And we can't have a stack of 100,000. Is it 100? Yes, 100,000. We can't have 100,000 stack frames. Now this N here means that we should have failed, but I think we shouldn't probably have failed with a Stack Overflow. We should have failed with some sort of message that says the JSON structure wasn't valid. It would be interesting to know how far we got. Let's see how many of those there are. And the answer is the nice round 1024. So we seem to have a stack depth of 1024 frames before we bombed. I don't think I'm unhappy with that. We'd have to do a lot of work in our parser to get a better error message. We could remember the depth and fail with a better message, but 100,000 opening arrays without doing anything is really a pathological case. The issue, of course, is though that if we're accepting input from the internet, maybe throwing an error rather than exception is a bit of an unsafe thing to do. I think I'm going to leave this test here so we're forced to think about it. Let's give it a better name. Let's give it the name of the test here. That's this one. And I think probably we'll say we expect this to fail by throwing, but we'd rather this through with an illegal argument exception rather than the Stack Overflow that we actually get. So let's run that again, check that we now have a failing test. Good. Check the message. That's about right. Now then, I think we may want to allow ourselves some failures. So what I think we should do is run all of the tests and collect the results before we decide whether this test here has passed or failed. To get there, I think we will have ourselves an enumeration of status, which is either pass or fail. And let's use that first of all is our status here. And then we can say that is fail else pass, importing the right things. This is fail else pass. And if we import from status, that will give us that. Now let's create ourselves a data class to represent everything about a test. So we'll have here a data class test, I think info maybe. And what do we want to remember? We want to remember the file it came from. We want to remember the status. And we want to remember the result as a string. So maybe I'll call that result as string. And so now in here, if we create one of those, we can say val test info is our test info given our file, our status, and our result, which we'll have to do a toString on. Now in here we can use testinfo.file. The first bit is testinfo.status. We've forgotten the file content, so let's put that in here as val contents as a string. So we'll put that in here as contents. That allows this to be testinfo.contents and this to be testinfo.result as string, take 100. Now why have I done that? Well, I think it allows me to create a function out of all of this. So I'm going to take that, break, it turns out IntelliJ, don't know why, don't know what broke there, but we should be able to take this thing out of here into the top level. And now we should be able to get rid of these variables by moving the test info into the try. So I think here we'll say return test info there. We'll do the same thing in there. That's not reachable. And now we can make this a val, and this a val, this a val, and this a val. These can go and run that. Well, you may be able to tell from my change of background that I got a bit distracted, and in fact I've moved a few hundred miles since I last ran the tests. What I think I'm going to do now is split this for each into a map and then a for each. So in here we can say map, and the thing inside that map will be a file. We'll just move that there, and then we'll move this test info up into there and that file up into there like that. And then inside the for each, we have a test info. So that's going to be test info, or at least it would be if we allowed that to escape. So we take that out of there like that. Going to undo that format because it looks like we needed one fewer brackets there. That's better. Now I know we can split a string template expansion in the middle, but that's a bit ugly. What I'm going to do is I'm going to undo that, take this whole string here, make it into a function, which we're going to call toString. Then if we make the test info the receiver, and then we can take that out of here and move it onto our test info by taking away that extension receiver. That needs to be override. Then we can put all of that on one line. That's better. And now, a little thing here, it's offering to take this return out the try. I suppose that's better. And going back up again, we can now sort by our test info. So in here, first of all, I'm going to say sorted by test info, and we'll do test info dot status, and then run the for each. Let's run that. Now then, that would have sorted all of our failures down to the bottom. So let's go and have a look. There they are. And you can see we have some failures starting with string and some with number and one with structure. So it'd be good to group those together as well, I think. First of all, let's sort our failures to the top. Is it reversed? Sorted by descending. Let's do that. Also, I think before we go on, this one's taking a long time, but we were testing it separately. So let's take that. We'll say filter not file.name is equal to that thing.json. So we won't run that one. Then we'll go and get the test infos. And before we sort by the status, let's sort by this thing here. So in here, we'll say sorted by, this is our file, and we want to take the file.name. I don't have the file name, but I can get it from the test info. That's what we've got here. So we're going to test info to testinfo.file.name. We're going to split that on the underscore. And the second one of those, at index 1, will be this bit of the name. So we'll bring those together. Then sorted by descending. Does that work like that? It's a bit better, isn't it? Let's run that. There we go. And now you can see here we have our failures. We have 1, 2, well, over 10, I'd say, were about number format. Then we have string escaped control character, string unescaped tab, string unescaped new line, and then a structure whitespace with form feed. But I think that's really about escaping as well, but it's hidden inside a structure. Okay. Now these number format issues are all about numbers that we can parse but shouldn't. And I think our issue here is that in our actual parsing, here, once we've collected our characters, we pass them to big decimal. And it turns out that big decimal is happy to parse -2 dot as a valid number, but it shouldn't be in JavaScript. So really we have to make our parser a bit worse in order to make it a conforming JavaScript parser. Maybe it's a thing we'd like to hide behind a flag at some point, but let's see whether we can fix this with a regular expression. So I'm going to ask AI Assistant to write a regular expression to say whether a string is a valid JavaScript number. Oh, I've been an idiot. I said JavaScript number, so it's given us a regular expression that matches hex numbers and so on. Let's try that again with write a regex to tell if a string is a valid JSON number. Okay, well, it's quite complicated, but let's give it a go. I can never remember how to test for a match with a regex. So let's say, how do I use that in Kotlin? Okay then. So I think we'll put that in a little function in here. We'll say fun string is valid number. That wants to return a Boolean. And this says we get a regex and return this matches the regex. And now in here, I think let's put in a brace to give us some space. We'll say if the string is a valid number, we want that, else, in this case I think we'll throw illegal argument exception with not a valid number. Let's see how AI Assistant has done for us. And the answer is that's fixed all of the number issues that we had. Well, way to go, ChatGPT. Thank you very much. I think we could tighten this up a bit just by pulling this regex out of here into here as a private val number regex. And then I think probably we can inline that as in here, string matches number regex is pretty self-explanatory. And in fact, I think we might even get rid of those braces. Now then, what failures do we have left? Well, the bottom one here is structure whitespace form feed.json. I'm going to go and look that up. Right then, here in parsing JSON is a minefield. It says RFC 8259 describes a whitespaces as space, tab, line feed, and character return, but it seems not form feed. I'm betting that our definition of whitespace includes form feed. So maybe we'll just take this list here and write our own definition. So we'll take this, go back, and at the moment, for example, in array state, we are using, where is it? Is whitespace here. So we're using that as a separator. And I think maybe that's the thing we should write our own. So let's go down the bottom of the file. We'll write private fun char is JSON whitespace. And that is going to be this equals. And maybe the easiest thing to do is make the Unicode escape. So we'll say I suppose we could create a string with those things in and ask whether our character was in that string, but this is explicit and fast. So let's take that thing. And now in here, we'll look for is whitespace. We've got 1 there, 2, 3, 4, 5, 6, 7, 8, 9 places. Let's replace them all with is JSON whitespace and run our tests again. Okay, that's got us down to only 3 failing tests. The first one is an unescaped control character. Second one is an unescaped tab inside a string. And the third one is an unescaped new line inside a string. So all these are inside a string. So it looks like we're just being too liberal in what we accept inside our characters in a string state. Let's have a look. So here's string state. And in our unescaped state here, then we're just appending the character. Let's go and have a look at what the web page says about those. Okay, this is in the section on strings, and it says here, control characters must be escaped and are defined as U000 through U1 through 1F. So let's take that. And in here we'll say if char is JSON control character, throw illegal argument exception with illegal character. I think we'll give the code in there because they won't be printable, so we'll say with code in string. And that code is going to be char.code. Now we don't yet have this thing, so we can create it here. And this is going to say, now what did we say in here? We said U0 through 1F. So I can never get ranges right, so I'm going to write it by hand. I'm going to say return this is greater than or equal to the character which is \U0000, and this is less than or equal to \U001F. IntelliJ will do a better thing for us. Convert that to expression, delete that, make it all one line. I don't know why we have Java lang string builder in there, but we'll fix that while we're here. And run the tests again. And oh my goodness, we have all passing tests. So we're now 100% compliant according to JSON Test Suites. Brilliant. Now it occurs to me that in my excitement to get all these tests passing, I haven't really written unit tests for some of those cases, and in particular for their error messages. So I think maybe I'll do that, but I'll do it on fast forward. So cue that funky music. And there we go, so unit tests. I think it's probably a good place to check in. Let's see what we've done. We've tested with all of the JSON Test Suite tests, and they're all passing. We have a small issue here where we're failing with an error, not an exception, which I think I'm going to let go for now. Our JSON tests have changed because I've added some unit tests for characters and numbers. And the JSON itself, well, we've changed the definition of whitespace to be JSON whitespace, and we've added a regular expression so that we can discard numbers that we were able to parse before but aren't valid JSON. In some ways that's a retrograde step, but hey, we are passing all the JSON Test Suite tests. So I think this is test against JSON Test Suites and fix number parsing and control characters and whitespace issues. Good. This has been a pleasing session. The JSON Test Suite has shown that our test-driven code pretty solidly meets the specification, and where it wasn't, it was quite easily fixed. I suppose we've cheated a bit by pre-screening numbers with a regular expression. Perhaps we should write a state machine to represent numbers, but overall I'm pleased with the current state of the code. If you're feeling pedantic, you may well be thinking that the JSON Test Suite tests don't actually show that we return the right result from our parser, just that we fail to return a result for the right inputs. That's a good point. To have ultimate confidence, we are going to want to create a range of inputs, convert those to valid JSON, and show that our parser interprets that JSON as the original input. That sounds like an interesting testing task to take on next week, So now would be a great time to subscribe to the channel to make sure you don't miss it. Click the thumbs up to give me a little dopamine shot, and finally get around to ordering a copy of the book that I wrote in that price called Java to Kotlin, a Refactoring Guidebook, details of which are in the show notes below. Thanks for watching.